All right, so I made a note on my note card of where we stopped on Thursday. So today is March 18th. And this is just, again, exponential equations. And this is continued from March 14th by day. So this, you understanding today's lecture is, of course, predicated on the assumption that you were either here Thursday or that if you were not, that you did your due diligence and, of course, watched the video and took notes just like the rest of us. To solve exponential equations, we're going to use that awesome property where we take the exponent and we bring it down. But there are some things that have to happen first. And the big one, really, sort of the battle cry, if you will, for the next several days is you got to get the power by itself. This thing in the yellow box is called a power. When you take a base and an exponent and put them together, we call that a power. So like x squared is called a power. 4 to the third is called a power. Anything that consists of a base and an exponent is called a power. So as I say, get the power by itself, I'm referring to that thing that I have up there in the yellow box, okay? So we're going to employ some really simple basic algebra in the first little bit before we actually use any high school math. So what's the first thing we would have to do to get the power by itself? You don't have to raise your hand. Be more specific.
What if you did 12 plus 3?
Sir, if you do 12 plus 3, you will never pass another math test again. So don't do that. That's poo-pooing the order of operations, right? That's like saying I put plus ahead of everything else, right? So if I say 12 plus 3 times blah, you better know that that 12 and that 3 are not allowed to go together. So right, you have to subtract 12 because the 12 is a detached term. And any detached terms by plus or minus, they should always be removed from the situation first. So we're going to subtract 12 on both sides. And that's going to leave us with 3 times the thing we're trying to get by itself. And then if you subtract 12 from an already negative 9,562, you get a negative 9,574. And I will show my work for anyone who's interested. That's minus 12. And minus 12, right? Just like we learned years ago. Again, I'm not ready. I'm not ready to do the thing. I still have to divide by 3, right? So I'm going to take both sides of this equation and I'm going to divide both sides by 3. Hello, Blair. Thank you. And I'm going to get 8 to the power of 5x equals whatever this is. 2. It's not going to come out evenly. This, much like Thursday, if you do not have a calculator in front of you, you'll get less out of today's lesson than someone who does. So I think by March 18th, it's safe to assume you've all got one with you. So if you type in negative 9574 divided by 3, your calculator is going to give you a message. It's going to say, don't write this down. That's what it says. Don't write this down. You do not want to take negative 3191.3 repeating and put that on your paper. So instead, what we're going to do for the remainder of this problem is we're going to tote this answer around as a fraction. And the reason we do that is because we want to maintain super high levels of accuracy until the end. The moment you call it a decimal and you say, oh, it's about negative 3191.33, ruined, dead, right? So leave everything as fractions until the very end. And now we kick into what we learned on Thursday, and that is, okay, it's time to get that exponent down from out of the tree. And how do we do that? You have to take the log of both sides, first of all. I want to be able to take that 5x and say, you, sir, get down here so I can divide by your 5. But none of that is possible until you're working in the land of logarithms. So step 1 at this point in time is to take the log of both sides. So I'm going to take the log of 8 to the power of 5x, and I'm going to set that equal to the log of this really ugly fraction. This is where we currently sit. It is that action that enables us to do what we're about to do. And what we're about to do is the most awesome thing in the world. And it is, we're going to take this item in the red box and we are going to bring it down so that it is no longer inaccessible. Exponents are pretty much like, how am I going to get up there and deal with you? Well, I don't have to anymore. So I'm going to take the 5x and I'm going to remove it from its current state, bless you, and I'm going to move it down into the front. So far, so good. And as typically will be the case, it boils down to some very rudimentary algebra. Always keep your focus. Like, what are we trying to do? What are we trying to do? What are we trying to do? We're trying to find x. We're trying to get x by itself. Like, and we've paved the path now to the point where I'm ready. All I have to do is divide both sides by the two things that are keeping x from being by himself, and they are 5 and not 8, log of 8. So if I divide both sides by 5 and the log of 8, I'm done. So on the left-hand side, I'm going to show that, like I normally wouldn't go through this much work, but just for your notes for the first time, illustrate that the 5s are dead, the log 8s are dead, and we're left with hallelujah. Done. Now it's a matter of, ooh, how am I going to type that behemoth into my calculator? It's not bad. So here we go. To type it in, this is what it's going to look like. You're going to hit log. Your calculator is going to gift you the first parenthesis. And then inside of that, you're going to type negative 9,574 divided by 3. And then you're going to close parenthesis. Remember, you can always just use division as a fraction, right? Don't hit enter. No need. Now, you remember from Thursday what we have to do if we want to divide by more than one thing? Right. So the next thing I'm going to do is I'm going to hit divided by. Now, I need you to understand something. This divided by is the last thing I want my calculator to do. And if I'm not careful with the next step, like Tristan said, if I'm not careful with the next step, then my calculator is just going to do things from left to right. That's what someone programmed it to do. So I step in, I get in the way, and I insert my own parentheses. And I tell the calculator, I need you to do some stuff in these parentheses before you divide. And what's going to go in there? 5 log 8. And again, please remember that this white parenthesis that I just drew right down here, it's not mine, right? That's my calculator's. And I'm like, hey, this is an easy log for you, calculator. I'm just going to put an 8, but I do need to close you off. And then I'm missing, yes, I'm also missing a purple parenthesis because I need to tell the calculator that it's done denominatoring. That's not a word, but it totally should be. So if we type that in, I'm sorry, I've been too busy writing to get caught up to you. So we're going to do log of negative 9,574 divided by 3, close, divided by 5, log 8, close, close. Oh, did you guys get an error message?
Yeah.
Why? No. So note to self, I may want to redo this example prior to 5th hour, but I'm super glad that we got to do this. I thought I typed something in wrong, and then I was like, oh, dude, get good, noob. Come on, why we get an error message? I'll give you a hint. It might just have some red arrows pointing to it. I'm not saying that that's it, but it could. Because you can't take the log of a negative, right? So my bad. Well, that was kind of fun though, right? Boy, apparently I should rewrite that example. Why did I put a negative on the? Well, here's what I'm going to do for fifth hour. Did you learn anything from that?
Yeah,
Oh, you did? I still think I should take the negative. There you go. Good. Yeah. So anyways, that equation has no solution. Marbar. All right, ready for the next one? All right. Oh, let me make sure that this one won't have any negatives. Okay, good. I think we're in good shape here. Can you imagine if you didn't know how to use logarithms and someone locked you in a room and said, I'll be back in 2 hours. You better have an answer for me. Here's a calculator, but it has no logarithm button. Good luck, sucker. That'd be really hard, eh? So I know, scary. Is the power by itself? Not only can we drop the negative, but we must. And this is probably once you learn this and you practice, like every unit has like a, okay, we're good at this, but we still like to do this mistake. This will be the Klinger honor mistake, is people saying, oh, I'm ready to log both sides. No, you're not. This is the power. I need you to understand that's the power. And so the answer to the question, can I drop the negative, is you must. You don't, you're out of luck. So what we're going to do is we're going to divide both sides by a negative. And if I divide both sides by a negative, what really winds up happening, watch the screen, is this negative goes away and this negative goes away. And now the power is by itself. So what do? Log both sides. Good. And why did we log both sides? What was the purpose? So we can move the exponent down. Like if you couldn't answer that question, I have failed you. That is why we log both sides, is to get that exponent down. Our variable's hiding from us. We need him down here. Okay, I can't perform algebraic maneuvers on him when he's chicken pooing up in the tree, but I can bring him down and then do my thing. So I'm going to take the negative 2.4x minus 5. And I'm going to bring it down. And it's now going to be multiplied by the log of 9. And we should all arrive at this point. You saw an example similar to this on Thursday. What's the next step? I do want to get x by itself, but the trouble with x is he's hiding from me. And again, it's like, great, I got you down out of the exponent, and now you're going to chicken poo hide in a set of parentheses. Blair, what do we do next?
divide both sides by a log of
I agree. Good use of your resources there. Excellent work. We divide both sides by the log of 9. And the reason we do that is because if the log of 9 isn't there, the parentheses don't exist anymore. They only exist because that annoying guy is on the outside, like, let me in, let me in. So if I divide both sides, then everyone is now free to move about the cabin. Watch the parentheses just fall away. Negative 2.4x minus 5, free and clear, is equal to log of 56 million divided by log of 9. Now, what this does is this opens up now just a chain sort of algebraic reaction of just, okay, I know to do this and then this and then this. And so just talk yourself through the algebra. What are the remaining steps to get x by himself? Don't question it. Like there's no way that you don't know the answer to this question. Add 5. Like you just know adding 5 is the logical next algebraic move. And what's the step after that? Divide by negative 2.4. Right. Like this is basic algebra. Get x by itself, you got to move stuff. So the way this one's going to look in our calculator is we're going to do the following. And again, I'll write it up here for you and kind of walk you through, and then I'll get behind, and then I'll get caught up to you in a minute. It's going to wind up looking like this. Log, calculator opens a set, and I type in 56 million. Careful with your zeros since you can't put commas into a calculator. Divided by log of 9. If at that point you want to hit enter, just for some odd reason, you are welcome to, but it serves no benefit. Now, as that answer sits there waiting to be calculated, what's the next guy scooting over? Plus 5. At this point, you must hit equals or enter, because if you don't, the calculator's going to, I mean, it's not going to mess up. We're going to mess up. It's going to do them in the order that we don't want it to do them in. So at this point, I need it to calculate the answer to the quotient to those logs plus 5. So let me get caught up to you. We should all be looking at 13.11972633 or something very close to that. Good? Okay, now let's think about where we are in the situation. We've moved the 5 across. What's the last thing we have to do? So with that on your screen, remember, don't be copying a bunch of garbage down on your paper. Just let the calculator hold it in its memory. So with that number on your screen, just hit divided by, and it knows you want it to divide by the previous answer. Divide by negative 2.4. And you'll be rounding everything to 4 decimal places. So for this one, we would say x is approximately equal to negative 5.4666. This number that I'm going to underline in red, what did it used to be? But what was next to it? Another 5. So that's why I rounded it up to a 6. Got it? Bless you. Let's do one more. And then it's just work day after this, okay? Oh, sorry. You guys keep seeing you trying to write stuff down and then start scrolling. So here's the next one. Can I scroll past the last example? There are 2 steps necessary to get the power by itself. What are they? In order. No doubt about it. Subtract that 561. So if I subtract the 561 from both sides, my next step would say negative 10 to the 4x plus 1 equals negative 100,560. And then you drop the negative. So remember that this does not count. I could say this 50 times, and there's always going to be 1 or 2 people every year who don't hear it. So here comes, I think, the second or third time. That is not a power by itself. Clear? The negative is no different than a 3 or a 10 or a 4. It's a negative 1, and it needs to be dealt with, right? So we're going to drop the negative off of both sides, leaving with this. And then we do our thing. So what do? Say those 3 sweet words. Log both sides. We're at that point where that's what we do. So here comes the next step. And I tried to fool you with this on Thursday, and you guys caught it pretty dang quick. Did I make a mistake?
No.
I did not. Certainly to someone kind of half paying attention, half lost, they might go, oh, what happened to the log, right? What happened to the log on the left? It's the log of 10. And so anytime we get that little benefit with a log of 10 or a natural log of e, we're like, hey, jackpot, baby. The log of 10 is 1, so it just kind of goes poof, right? So that saves us a little bit of time. Not a lot, but a little bit. So at this point, there's no more work that I would expect you to show on a test. Like from this point, I expect you to go to the answer. So the sequence that we type things in, I understand from here is going to go full calculator mode. So let's do this. So we're going to type it in as, I'll just show you down here in yellow. We're going to do log. It's going to open a parenthesis. We're going to type in 100561. We're going to shut that down. And then what's the next step in this process? We got to subtract 1. And what must we do? You must press enter. If I'm going to write it in the notes in red in all capital letters, I can't tell you enough how important that is. You must block the process at that point. Tell the calculator, figure this out first. Then, with that decimal sitting on our screen, what do? Right, then we divide by 4. If you don't want to press enter, I will just say this because someone's going to ask, could I have put this in parentheses? Yes, but most people don't want to do that. So it's safe just to hit enter when you know we're supposed to calculate or plus or minus. So I see log of 100561, shut it down, -1. My calculator says 4.002429583. And with that number on the screen, what do? Now I hit just divide by 4, and we should all get 1.001. Does that sound about right? 7 or 000? So no, it's just 0006. Yeah, apparently I forgot how to round over the weekend. So this would be x is approximately equal to 1.00006. Forgot what we were rounding to. So there you go. Good. That is how you solve exponential equations. And I have an assignment, and I have 2 assignments, but I'm only going to give you one of them today. So let's get to it. Pause this.